Yeah, welcome to Steph's Academic Nutrition Center. I want us to do chemistry under electronic configuration. So electronic configuration. So to talk about electronic configuration, in simple term, we are saying that this is the arrangement of electrons in shells of atoms. So electronic configuration is the arrangement of electrons in shells of an atom, or I can say electronic configuration is the arrangement of electrons in shells of atoms. So, the maximum number of electrons each shell can accommodate is given by this formula, which is 2 n to the power 2. This is a formula for the maximum number of electrons each shell can accommodate. So 2 to the power n, 2n to the power 2, 2n to the power 2. So where n is the number of shells. So our first shell, second shell, third shell, fourth shell, etc. So n, it stands for number of shells. For example, this is just an example. This is a structure of an atom. This is the first shell, the second shell, the third shell, the fourth shell, etc. So this first shell, the shell number 1, shell number 2, shell number 3, shell number 4. So each shell, it has got what we call the maximum number of electrons that it can accommodate. So we'll start with the first shell here. The first shell here, which means we're going to say first shell, we're going to say 2 to the power, 2n to the power 2, where n stands for the number of shells. So the first shell here, the first shell is 1. So we're going to put 1 here while there's n. So 2, then 1 here, then to the power 2. And so we'll say 2, then we're going to say 1 times 1, which is 1. 1 here. Then again, 2 times 1 is 2. So the first shell is supposed to carry a 2 or accommodate 2 electrons. So the 2 electrons, I'm going to put them like this, 1, 2 here. So as you can see, these are 2 electrons. So if I want, I can use the dot of representing the electron like this. Is the same. If I want, I can use the cross or the dot to show the electrons. Then number second shell, again, I'm going to say 2 to the power 2n to the power 2 like this. Then I'll say 2, n is 2 here, then to the power 2. So this means that 2 times 2 is 4. 4 times 2 is 8. So 8 here. So again, the second shell is carrying or accommodate 8 electrons. So I'm going to put 8 here. So 2 here, 4 here, 6 here, then 8 here. So as you can see, I have 8 electrons in the second shell. So 2, 4, 6, 8. 8 electrons in the second shell. Then again, I'll continue doing the same. The third shell again, which means I'm going to put 3 here. So I'll say 2, 3 here to the power 2. So 3 times 3, 9. 9 times 2, 18. So 18. So the third shell is carrying the maximum of what? Of 18 electrons. So you do the same thing until you reach the number of shell that has been asked for you to find. So this is how you're supposed to find the number of electron in each shell, or the number of electron in a given shell. So now we need to know that. For example, I'll try to explain this part as well. For example, if you have maybe, for example, like we have sodium here. My sodium is here. Sodium, which is we have 23 here. We have 11 here. Good. So when they tell me to write the configuration for sodium, so I'll do like this. Since sodium electron configuration, which means the word electron, which means I need to get the electron number. So I can look for sodium on the periodic table. This is my periodic table. So as you can see, sodium here, there's 23, there's 11 here. So this is what we call its atomic number, proton number, or electron number. So the electron number is 11 for sodium. then I'll say, since the first shell can accommodate 2 electrons, so I'll put 2 electrons here, like this. The next one is second shell, which can accommodate 8 electrons, so the next one is 8. Then now when I add this plus this to give me 10. So now this is 11. So it means I've remained with 1 electron. So I'll put this one at the end there. So this is the configuration for sodium. Then now when they tell me to draw, so I need to draw. So I'll write sodium here, the symbol of an atom. Then the first shell is what? 2 electrons. So I'll put 2 electrons here. I'll put 2 electrons. So I say 1, 2 here. The second shell is what? 8. So I'll put 1, 2, 3, 4, 5, 6, 7, 8. Then the next shell is 1 electron. Good. So which means I have 11 electrons. So the last shell here, the last electron here, we have 1. So this last shell, or the last electron, the outermost shell, this one indicates the group of an element. So for example, like since this sodium atom, it has got 1 electron in the outermost shell, which means it's in group 1. Group 1. So the number of outermost shell indicate the group of an element. Then the number of shells, example like number of shells, example I've got 1, 2, 3. Since I have 3 shells, so it means the number of shell indicate the period. So sodium is in period 3. So now how do you know this period 1 is period 2? So this is my period table. So groups, these are vertical lines. So as you can see, we have group here. So this is group 1. So all these are in group 1. Then in group 2, as you can see, there's 2 here. So this is group 2. Then these metals here from here to here, they don't, these from here to here, they don't belong to any group. So here I have group 3, as you can see, group 4, group V, which is group 5, group 6, group 7, group 8. So O is group 8. Then again, this zigzag line drawn here, this is zigzag line, it separates metal from non-metal. So the element on the left-hand side of the zigzag line, this line, these are metals. While the metals on the right-hand side of the zigzag line, these are non-metals, which means we have got more metals compared to non-metals. So these are non-metals and these are metals. Good. So since I'm saying that sodium is in group 1, and we try to check sodium group 1, check group 1 here. As you can see, sodium is here, so it's in group 1. And then period, how do you count a period? You count period from hydrogen here, period 1, period 2, period 3. So as you can see, sodium is in period 3. We're counting from here 1, the first line here 1, the first line here 1 here, then 2, 3, 4, 5, 6, 7, which means we have 7 periods on the period table. So we have sodium is in group what? Period what? Period 1, 2, 3. So sodium is in period 3. This is period 3. So the number of shells indicate the period of an element, and then the outermost shell, this number at the end, at the last shell here, indicate the group of an element. I'll get another example. I'll go for oxygen. Oxygen is here, as you can see, we have oxygen 16 here, then 8 here. So I'll write the configuration and the structure. So oxygen is like this. So I have 16 here and 8 here. So I'll write the configuration first. So since we know that the first shell carries 2 electrons, so I'll write 2 here. So 2, comma. So now, so from 8, when we remove 2, we'll get what? You remain with 6. So I'm going to put a 6 here, because it can't reach up to 8. So I'll just write the 6, the remainder. So now from here, I'll put O here, then I'll The first shell, I have two electrons, so I put 1, 2 electron. The next one is 1, 2, 3, 6. Absolutely. So 2, 4, 6. So I have 6 electron in the atmosphere. So these numbers, the last electron, it indicates the group of an element. So the group here, group. Then on count 1, 2, 2 each. The what? It indicates the what? The period. Good. So the last number here, 6. The last number here indicates the group of an element, and which is the group what? Group 6. Then the number of shells, 1, 2, indicate the period. So try to check. Try to check for oxygen is here. So oxygen, as you can see, in group what? Group 6. Period what? Period 1, 2. So it's in period 2. So this is how we are supposed to show the electronic configuration, the arrangement of electrons in a shell of an atom. Good. So now, so note that metals have 1 or 2 or 3 electrons in the outermost shell. So we're saying that all metals that have got is either 1 or 2 or 3 electron in the outermost shell. So when you just see an element with 1 electron or 2 electron or 3 electron in the outer shell, just know that it's a metal. The non-metals, they have got 4 or 5 or 6 or 7 electron in the outermost shell. So metals have got 4 or 5 or 6 or 7 electron in the outermost shell. So this is how you can know whether an element is a metal or non-metal. Then again, in terms of configuration, we can show by drawing, by writing. So when they say write, you write like this, the configuration. When they say draw, you draw like this. So this is how you are supposed to show the configuration. Then we go to ions. An ion. So talk about an ion. An ion is a charged particle. So we call this one is a charged. It's a charge. Particle. So an ion is a charged particle. So when they ask you what's an ion, so an ion is a charged particle. Then there are 2 types of ion, which is cation and anion. So there are 2 types of ion. You have cation or cation and anion or anion. Good. So now, on talk about, in fact, I'll start with cation. So cation is it's a positively. These are positively charged ion. So cation is a positive charged ion. So all metals form cation. So all metals, they form cation. So metals, in fact, they lose electrons. They can lose either 1, 2, or 3 electrons to form cation. For example, I'll start with sodium. Sodium like this. 23 here, then 11 here. So I'll write configuration for sodium, so which is 2,8, 1. So as you can see, this sodium is supposed to have 2,8, or 2,8. So since I said element with 1 or 2 or 3 electron in the outermost shell, it is a what? It's a metal. So sodium, for it to be stable, is supposed to lose this 1 electron here. So since it's losing 1 electron, so it will form a positive. So it will have sodium +1 like this. So we can write +1, but we can ignore 1. We can just write sodium and positive. So it shows that sodium lost 1 electron in order to be stable. So the configuration for sodium ion. So this now will be sodium ion. But this one without a charge, it's a sodium atom, because it has got no charge. But this one with a charge is a sodium ion. So sodium, it's a sodium ion because it lost 1 electron. So in this case, the configuration for sodium ion will change. Since this 1 electron is lost, so we have 2,8 as a final configuration for sodium ion because it lost a single electron. So when an atom lost single electron, it is called, so we have got monovalent cation, also have divalent cation, also have a trivalent cation. So all these are cations. So monovalent cation, which means that an atom lost single electron. A divalent cation, it means that an atom lost 2 chi-diamonds to 2 electrons. Trivalent means an atom lost 3 electrons. So don't forget that when an atom loses electron, the configuration changes. We maintain configuration for the sodium ion, which means we exclude or remove the part or the number of electrons which has been lost. Good. For example, we have magnesium like this, 24 here, we have 12 here. So we need to come up with a configuration for this one. So to be this is it has no charge, so it's a magnesium atom. A neutral, it's neutral, which means without charge. Neutral magnesium atom without a charge. So this one, after now undergoing the reaction, we have 2,8,2. So as you can see, this one, the last number shows that it's in group 2 of the periodic table. Apart from that, it lost 2 electrons because 2,8. So this electron is supposed to be lost. So we have magnesium and 2 like this. So which means the 2 electrons were lost. Since it lost, it is losing 2 electrons. So equal to divalent cation. So don't forget, magnesium will lose 2 electrons. And I say that the metals that have got the last shell or the valence means the number of an electron atom supposed to gain or lose. So metals have got 1, 2, or 3, and these electrons need to be lost. And when they lose this electron, they form a positively charged ion, which is cation. So in this case, we have 1, 2, 3. These are for metals. You see, they can have 1, 2, or 3 in the outermost shell. So they need to lose these electrons. Then for 4, 5, 6, 7, these are metals, and then to gain. And when we reach at this point, I'll explain more on this patch. So this is the cation patch. Then now I'll go to the next part, which is an ion. So these are negatively charged ion, or particle. So an ion is a negatively charged particle. So all nonmetals they gain. So all nonmetals they gain. These they gain electrons. So all nonmetals they gain electrons. All nonmetals they gain electrons. So after gaining electrons, they form a negative charged particle. For example, like oxygen like this. We have 16 here, we have 8 here. So it means we have 2,6. So 2,6 is supposed to be 8. So since I said from 4, 5, 6, 7, this they gain, and they are nonmetals. So which means oxygen is supposed to gain 2 electrons. So after gaining 2 electrons, it will have 2,8. So which means since it's gaining 2 electrons, so we are going to put 2 negative here. So this is oxygen, oxide ion. Yeah, oxide ion. So this oxide ion, which means it gained two electron. And since it gained 2 electron is similar to cation, so we have mono valent anion. Also we have divalent anion and trivalent anion. So monovalent anion, it gains 1 electron. Mono means 1 single electron. Then divalent anion, it gains 2 electrons. A trivalent anion, it gains 3 electrons. So this was about an ion. So don't forget, an ion is a charged particle. Then we have 2 types of an ion, which is the ion amine, which is the cation and the anion. Then I'll try to, in the next video, I'll try to give you exercise or task. The next topic is chemical bonding. So don't forget to go through the notes. This is just a simple explanation. Thank you very much.